Hi students, today we are starting Unit 3, Advances in Interpretable Machine Learning. Okay, so till now we have studied machine learning models, but today we are going to see something different. Not just how the models are predicted, but how the models explain their prediction. What is that? How models are predicted, not how models explain their predictions. Okay, so is accuracy alone enough in real world AI system? That is what we are going to explore today. Okay, the question answer is that is what we are going to explore today. So the content talk about the understanding AI decision, transparency and trust. Students, today AI systems are taking the decision for humans. For example, loan approval, medical diagnosis, hiring decisions. So, one important question arises, can we trust AI? Listen, can we trust AI? So, if we don't understand how AI decides, we can't fully trust it. Okay. So, this unit focuses on understanding the AI decision, making the system transparent, building the trust. So, transparency equal to no hidden logic. Trust equal to confidence in system output. Clear? Okay, now the ML models are widely used. Many behave as their black boxes. Interpretability helps understand reasoning. So now think about the deep learning models. They have many hidden layers, thousands of parameters. Okay, many hidden layers, thousands of parameters. Can we manually trace every calculation? No, exactly. That is why they are called the black box models. Okay. So black box model is input, then go for the hidden processing, then go for the output. But internal logic is not visible. So interpretability mainly help us to understand why did the model give the output. Okay. Why did the model give the output? Okay. That's what we have to using the interpretability concept. Why interpretability is important? First one, it builds the trust. It identifies the bias and unfair decisions. And it's also support the legal and ethical, and it improve the accountability of automated decision. And it also assess the debugging and improve the model. Okay, I want to explain. Let's take an example. Suppose an AI system reject the female candidate more than male candidates. If a model is not interpretable, we can't detect bias. But if we can see the feature importance, we can detect discriminations. Okay, so explain the each point: trust, bias, bias reduction, legal compliance, accountability, debugging errors. Okay, so in healthcare and the banking, explanation is compulsory. Okay, in the healthcare and the banking, explanation is compulsory. Okay, interpretable algorithms. It is transparent by the design. These algorithms are. And the decision logic is directly visible to the user. Decision logic is directly visible to the user and easy to trace how the input lead to the outputs. So which means no extra tools are required. Okay. And then suitable for critical applications. Okay. So these models are simple and understandable. For example, I would like to tell decision tree. If attendance less than 75%, the student will be not eligible to attend the examinations like a FAT and SAT. Okay. If the attendance less than 75, the student will not be eligible for the FAT and SAT examinations. And then linear regression, and the weight shows the impact of the future. So here the explanation built in. Okay, we don't need extra tools. Okay, so which is easier to explain to non-technical person. So decision tree or deep neural network. Clear? So examples of interpretable models. It include the linear regression. Okay, linear regression provide the clear weight and the interpretations. And then second one is decision tree. Decision tree follow the clear if else rules. And the rule-based model. The rule-based model, it is also used the explicit logical conditions. Then scoring system, it assign the numerical importance to the feature. And then simple Bayesian models, it offer a probability of interpretations. Okay, so it include the linear regression, decision tree, rule-based, scoring system, Bayesian model. Okay, so linear regression is weight explain the impact. Decision tree if else path. Rule based clear logical rules. Scoring system points assigned. Bayesian probabilistic reasoning. Okay. So keep it simple and real life. Okay. Then complex internal structure. Explainable algorithm have a complex internal structure. Okay. So this model decision are not directly interpretable. Okay, fine. The explanations are generated after the prediction, which means need the external tools it requires for better understanding and then offer the higher accuracy. Okay, so these are the high performance model like deep learning, random forest and then boosting. Okay, deep learning, random forest and then boosting. Okay, so they give the good accuracy, but understanding the internal structure is very difficult. So we use the explanation tool after prediction. Okay, that is called post-hoc explanations. Okay, that is called post-hoc explanations. So these are the clear difference between interpretable and explainable algorithm. What is that? Interpretable built in the transparency and simpler and lower complexity. But explainable, it's complex, need the extra tool and higher performance. Okay. So in the choices depends on the applications risk. Okay. Say for example, medical interpretability is preferred. Recommendation system accuracy is preferred. Okay. So these are the difference. The model classes, the linear and then score based, rule based, monotonic, sparse, additive, symbolic and neural networks. Okay, these are the actionability, non-actionable, counterfactual like that. Okay, so interpretable model explain the decision inherently. Explain model need a post-hoc method. Okay, so interpretable model prioritizes transparency. Explainable prioritizes the performance. Choice depends on the application risk. Okay. So already I told that if a medical, we have to choose the interpretability preferred. And in the recommendation system, we have to choose the accuracy preferred. Okay, need for the interpretability tools. Why we are need this? Because the complex models are difficult to analyze them manually, right? The complex models are difficult to analyze the manually. And the tools helps to visualize the model behavior, okay? And then they enable the feature importance analysis and the support error detections and debugging. Okay, then improve the user confidence in prediction. Okay, improve the user confidence in prediction. So the complex models are difficult. Tools visualize behavior, feature importance. Okay, so when the model has 1 million parameters, can we analyze manually? When a model has 1 million parameter, can we analyze manually? No. Okay, so the tools are visualize, feature importance, explain the local prediction, and detect the model error too. Okay. So that's why we have to need the interpretability tools. So remember one example, when a model has a 1 million parameter, can we analyze manually? Okay, that is the best example for need for interpretability tools. Okay, tools and libraries. First one, line. Okay, it explains the one prediction locally. Okay, it's explained the one prediction, after that another prediction, after that another one. Okay, so it explains individual prediction, which means at a time only one prediction. Sharp, it's a sharp provide the give the contribution value. Okay, give the contribution value, which means the contribution value may be consistent. Okay, and then ELI5. Okay, it offer the simple explanation, which means the just text based. Okay, simple explanation, which means the just text based. And then interpretable ML. Okay, it integrate the multiple explanations method, which means the combinations of framework. Okay, multiple combinations of frameworks are there. Okay, so these tools are improve the transparency and audibility. Okay, auditability. Okay, so these tools enhance the transparency and auditability. Okay, clear? So there are the main four tools: line, sharp, AL5 and interpreted ML. Then ensemble based techniques. Okay, ensemble based technique is combine the multiple model to improve the accuracy. Combine the multiple model to improve the accuracy. For example, random forest equal to many trees are combined. Okay, as you know that. And then boosting the sequential improvement. Okay, so individual model decisions are complex, but the feature important is a partial interpretation, which means the trade-off exists between accuracy and clarity. Okay, the feature importance give the partial explanation. Have you got it? Okay, students, in this slide, we are discussing decision tree based techniques. A decision tree is one of the most popular interpretable models in machine learning. It's work like a flowchart structure. At the top of we have a root node, which represent the first decision condition. Okay, then the tree split into the branches based on the different conditions. So each internal node represent a condition check. Finally, we reach a leaf node, which give the final prediction. Okay, so top of is root node, the branches based on different condition. Finally, we reach a leaf node, which give the final prediction. So the biggest advantage of decision tree is that we can easily trace the path from root to leaf, which means top to bottom, root to leaf. That means we can clearly understand why a particular decision was taken. Okay. For example, the example shows in the picture, if attendance less than 75%, it is not eligible. Okay. If attendance greater than or equal to 75% and internal mark greater than 40, it eligible. Okay. So this is a simple and human readable. That is why decision trees are highly interpretable and preferred in domains where the transparency is important. However, one limitations is that if the tree become a very deep, it become a complex and harder to interpret. Large trees reduce the clarity. Okay. Clear? Okay, now we move to rule-based techniques. Rule-based models use explicit if-then rules. What is that? If-then rules. These rules are easy to read and understand. For example, if age greater than 60 and BP is high, the risk equal to high. If a salary greater than 50,000 and credit score greater than 750, the loan may be approved. Here the logic is fully transparent. There is no hidden calculations here. So one major advantage is that domain experts can directly design these rules without deep machine learning knowledge. Okay. So these systems are commonly used in the expert systems, medical diagnosis support, fraud detection system. Since the rules are clear, they are easy to verify and validate. If something goes wrong, we can easily check with the rule cast problems. So the limitation is that rule-based system may not perform well with very complex or high dimensional data. Clear? Okay, in this slide we will discuss scoring systems. The scoring system assigns a numerical score to each feature. The total score determined to the final decision. For example, in a credit score scoring, salary equal to plus 10, good repayment history plus 20, late EMI minus 15. So after calculating the total score, if it is crosses a threshold, the loan is approved. So the advantages of scoring system is that each feature contributions is clearly visible. That make the system easy to explain the customer. So scoring systems are widely used in banking, insurance risk assessment, healthcare risk evaluation. They are the simple and interpretable and legally defensible. However, they may not capture very complex relationship in data compared to advanced ML models. So now we look at to the advantages and limitations. Advantages. So interpretable models improve the transparency. They increase the trust and accountability. They help detect bias and unfair decisions. They make debugging easier. The limitations are they may have lower accuracy for high complex data sets. They may not scale well for a very large data sets. Sometimes simple models can't capture the non-linear. The relationship is effectively. So again we see a trade-off between interpretability and accuracy. Okay, finally, interpretability is essential for responsible AI. So the transparent models support ethical decision making in sensitive domains like healthcare, finance, and law. Interpretability is very important. However, in some cases, the performance is prioritized over the interpretability. Therefore, the modern AI system aims to balance both. It has sky-high accuracy and clear explanations. So, future AI research focuses on developing the models that are both powerful and understandable. As an engineer's responsibility is not only to build the intelligent system, but also trustworthy system. AI should not only be accurate, it should also be accountable. Hope you understood. We will see you on next video and thank you so much.